Okay. So that y right there, that's the length of this red side. This purple side, that's the adjacent leg. Okay, that's equal to the x-coordinate. So whatever this length is, okay, that's the x-coordinate. However long that is. Right now it looks like it's 0.5. Okay, so just from the looks of this is going to end up being 1/2. Okay, so that length right there, guys, is equal to 1/2. And I'm getting that because I'm just looking right here. 0.5, that's 1/2. Okay. All right, now we want to figure out, well, what's the length of this red leg? Okay, so if you look at this right triangle here, guys, okay, this was 0.5. This is 90 degrees. R is equal to 1. There's R. And the radius of this circle, so that's 1. Okay. This is 1/2. What's the length of the opposite leg? This is the adjacent leg, and it's 1/2. Right? How would we figure out what this is? You know, two sides of a right triangle. Yep.
1/2 squared.
Yep.
Minus 1 squared.
Well, 1 is the hypotenuse, so you're going to have 1/2 squared. Okay, so if we did the Pythagorean theorem to this, I'd have 1/2 squared plus this opposite leg squared equals the hypotenuse squared. Okay, so 1/2 times 1/2 is 1/4. Okay, then I'm going to subtract 1/4. So 1 minus 1/4 is 3/4. And now I'm going to take the square root. So this length right here, and I'll do it down here, 1/2 squared plus what I'm looking for, squared, equals 1 squared. So that's 1/4 plus squared equals 1. Okay, and then I'm going to do squared equals 1 minus 1/4. which is 3/4. And then I'm going to do the square root. So that's going to be root 3 over square root of 4, 2. So I now know what this length is. It's root 3 over 2. Okay, so that's the value of y, root 3 over 2. So this is going to be root 3 over 2i. Nice. What do you need?
If we had a turkey bowl, which teachers versus students in a football game, would you want to play in it?
Yeah, sure.
Wayne said he wanted to, so.
Yeah, Weens can run. The rest of us, yeah. Well, I'll come in on short yardage plays.
Okay. Thank you.
Yeah. All right. So we got, this is root 3 over 2, and this is 1/2. Okay, any questions on where all that came from? I know it looks like a lot of math, but it's stuff that we've done before, or you've done before. All right. So, let's see, I'm going to zoom out here. Zoom out. Okay, now what this example is asking you to do is derive a formula for the complex number. All right, so right here, okay, this was 1/2, and this was root 3 over 2 I. Okay, this is called the rectangular form. This is what we've been doing. Rectangular form. The original one looked like this. It was z x plus y I. And we took out the letter x and we made it 1/2. And we took out the letter y and we made it root 3 over 2. Okay. All right, now what this part's asking you to do is we want to take this complex number and we want to write it in terms of its modulus and its angle. All right, so what we want to do is take this. Okay, right now this is when something's in rectangular form, guys, this is in terms of x and y. Okay, we want to end up with something that is in terms of r and theta. So when we're done, this thing's going to have r's and thetas in it. And that's going to be known as what's known as the polar form. Okay. All right, so if you remember back in the day when you learned about right triangle trig, we called this the adjacent leg, just like we did a few minutes ago. And we called this the opposite leg. And R is also the hypotenuse. All right. What coordinate is the adjacent the same as? The X or the Y? Yep. The adjacent is the X coordinate, and the opposite is the Y coordinate. So the opposite was √3/2, and the adjacent was 1/2. These were our two coordinates in yellow and green. Well, you can figure out what those coordinates are if you know the angle and the radius using trigonometry. All right, so if I just know this angle and this radius, I want to know what's the X coordinate. Okay, well, we know this. By definition, the cosine of an angle is equal to the adjacent leg divided by the hypotenuse. Okay, so I can say that this cosine is the same as X over R. X is the adjacent leg, R is the hypotenuse. Okay, now if you take that and you multiply both sides by R, you're going to have R times the cosine of the angle equals the X coordinate. So this is the X coordinate in terms of an angle and the radius. Okay, now what that lets me do, guys, is I can come up here and I can take that 1/2 and it's going to be the same as R times the cosine of the angle. This is the X coordinate. But notice now it's in terms of the radius and the angle. Plus, okay, let's just do it like this. Yeah. This is the Y coordinate, and it's going to be the same as R times the sine of the angle. Okay, so if we look right here, we know that the sine of an angle is equal to the opposite leg, which is the Y coordinate, opposite over hypotenuse, Y over R, and if I multiply both sides by R, that's the Y coordinate. So you can figure out what your Y coordinate is by knowing the angle and the radius. Okay, so this is going to be R sine theta. And that's going to get multiplied by I. Okay, so now this is Z in terms of R and theta. Okay, R. So you're just describing it a different way, and that's called the polar form. So it's like you're bilingual now. You can talk in rectangular form, you can talk in polar form. Okay, so this right here is how, whoops, let's get rid of that. This part in parentheses, that's the same as your y coordinate. All right, what angle is that? How big is this angle? Remember this coordinate right here is 1/2 root 3/2. And the radius is 1. Well, if you look at your unit circle, find those coordinates. Here they are. Okay, this length is 1/2, and this length is root 3/2, so this angle is 60 degrees. So that's a 60-degree angle. I figured that out because I knew the coordinates were 1/2 and root 3/2. So R is 1 cosine. This would be 60 degrees. And this would be 1 times the sine of 60 times I. Okay, if you're not sure how we got the 60, I'll write it over here on the side. That's how you got the 60 degrees. All right, can I move this? Yes, no, anybody still writing? Alrighty. So this is the formula then right up here. This is your formula for the polar form of an equation, of a complex number. Alrighty. Let's shrink this. All right, so this one says, what's the value of r and what are the coordinates of the points x and y in terms of theta? Okay, so in our problem up here, when it lies on a unit circle, right there, okay, unit circle has a radius of 1. Okay, so this is the radius, this is 1. Because it's a unit circle. Now to get the coordinates of x and y, but using theta. Okay, so the x coordinate was r cos theta. And the y coordinate was r sine theta. That's how you got each coordinate. Right, so I just took out this r and I put a 2 in there. Okay, if the radius was 20, I take out the r and I put a 20 in there. Okay, so if we were dealing with a radius, a circle that had a radius of 20, it's going to be 20 times the sine of the angle, and the y coordinate is going to be 20 times the cosine of the angle. Yes, sir. Ma'am.
Why is it switched?
Why is what switched?
Because the last two were...
Oh, yeah, thank you very much. Because I messed up. Thank you. Darn right. Cosine, sine. The way I remember, how do I know which one's which? C comes before S, just like X comes before Y. X, Y, Z. So when I would always try to remember, okay, which one's cosine and which one's sine? It's the same as the alphabet. X comes before Y, so C comes before S, so X is the cosine. That's how you can memorize or know the difference, which one's cos and which one's sine. Alrighty. All right, now this is when what this question's asking you to do, use the definitions to write the coordinates of the point x and y in terms of cosine and sine. This is when r is bigger than 0. Okay? So the examples that we've done right here, r is greater than 0. Here, r is bigger than 0. It was 20. Okay? So your x coordinate is simply r times the cos, and your y coordinate is r times the sine. Can r be a negative number? Can the radius of a circle be negative? No. R is always a positive value. Okay? That's why it says if r is greater than or equal to 0. So I said when r is something, it's not 1, it's something else. For example, r's 2 or r's 20. Okay, and then it says use the answer above to rewrite z equals x, that's the x coordinate, plus the y coordinate times I. So take this out, and I put in r cos and then I take this guy out and I put r sine. And then finally, they both have an r in it, so I'm going to factor out r. And this is called the polar form. Cosine theta plus I times the sine of theta. That's the polar form of a complex number. Okay, and if you remember, we had some vocabulary. R was known as the modulus. And how much you had to rotate it, that's known as the argument. So when you're asked to, what's the argument, it's asking you what's the angle. The argument is the angle. That's called the argument. All right. So what we're going to do is we're going to take this equation and we're going to translate it into rectangular form. Okay. All right. So to do that, A is the x coordinate. Okay. And we know that the x coordinate is equal to this. Okay. Right here. The x coordinate is equal to r cosine theta. So in this problem, A is equal to r cosine theta. All right? So R is, in this problem, R is 3 and theta is 60. So this is going to be 3 cosine 60 degrees. Okay, the y-coordinate is r times the sine of theta. So this is going to be 3 sine 60. Times I. And that's what it looks like in rectangular form. But we're not done yet. Okay. Go to your unit circle and look up the cosine of 60 degrees. And then go to your unit circle and look up the sine of 60 degrees. So on my unit circle, at 60 degrees, the cosine is 1/2 and the sine is √3/2. Cosine, sine. So that becomes 1/2, and this becomes √3/2. So 3/2 plus 3 √3/2i, and there it is. These two things are identical. This statement and this statement are the same thing. One's written in rectangular coordinates and the other one's written in polar coordinates. All right. Now this guy, we're going to convert the other way. We're going to take it from rectangular and convert it to polar. Okay, at the beginning, guys, we figured out at the very beginning of your notes, if you took that point right here, here it is, I'll circle it. Here's its modulus, and here's its angle. Okay, so if I want to convert this, okay, from our table, we know R is 2, and we know the angle was 90 degrees. Okay, so the way I got the 2 and the 90 was from the very first page. Right there. 290. All right? And now it's really simple to write in this form. So Z equals, let's see, R is 2, parenthesis, cosine theta is 90, plus I sine theta is 90. And there it is. That guy went right there. And this guy went there and there. Okay, almost done. All right, so what we're going to do here is we're just going to summarize this stuff. Okay, if something's written in polar form, the modulus is the variable r. So our modulus is r. Our argument is the letter theta. And if I want to get the x and the y coordinates, okay, the x coordinate is r cos theta, and the y coordinate is r sine theta, okay, when it's in rectangular form, to get the modulus, we write z and we put it absolute value bars around it. And we get it by taking the x coordinate and the y coordinate and squaring them and taking the square root. Right.
Can you go back up for a
Yep.
second?
Got it? Okay. Now this last part, in the chart at the beginning, guys, in this one we already figured these stuff out. This one had the modulus of this was -3, or 3, I'm sorry, and this was a 180-degree rotation. This has a modulus of 2, and it was a 90-degree rotation. This is from the very first page. This one had a modulus of 3 root 2, and it was a 45-degree angle. And this one, it had a modulus of 4, and it was a 300-degree rotation. So if you know those things, then you can write it in polar form. This would be 3 cosine 180 plus I times sine 180. And we'll stop there.